And now we'll go into section 11. All right. So thumbs up who's actually looked at the section 11, just like, even if it's briefly. So a little thumbs up, a little thumbs down. Okay, cool. It's okay if you haven't. I know project week just finished, so I know people are kind of doing their last tweaks on their project, which is totally understandable. Just know that this section, I find it to be relatively, well, I don't know. I don't like saying it's like easy or something like that because that's all relative. But I think this one's a little like nice little breather. It's JSON and XML. There's not like a huge amount of like data analytics part, but basically of how to deal with data. You can think of like section 2, basically of saying, how do we get data and how do we access all these things? So next time, for example, will be about APIs, okay? But right now we're gonna talk about JSON and XML files, okay? And then we'll talk about recursive functions, and then we'll very briefly, oh, sorry, I just realized this is a different, sorry, I'm thinking version 1 still. So, okay, good. So basically we'll talk about this. Know that there are, these are not the only file formats, JSON and XML. There are other file formats as well. But these are the most common ones that we'll get data from, right? And then we'll talk about how to recursively go through them if you haven't seen recursive functions yet. All right, so let me go ahead and open up my guy here, and cool. All right, so basically we're gonna talk about JSON, JSON. It sounds like Jason. I don't know if anyone pronounces it differently, but just know it's JavaScript object notation. And if anyone who has done any, web development or even heard, JavaScript, JavaScript is another programming language, similar to like how Python is. And basically, know that JSON objects are essentially valid JavaScript code. So you could literally copy and paste what we'll see as a JSON object. We can literally copy and paste it and put it into JavaScript, and JavaScript would understand what it's talking about. And what's kind of nice is that Python actually can use some of the JSON code itself. Or not JSON directly in its code. So we'll actually see how that looks like too. All right. So going from JSON, just know it comes from JavaScript object notation. I have a little bit of resources. So you can see like the file extension usually is .json, JSON, right? So that's kind of how you can see if it's an actual JSON file. Okay. And so kind of going forward, basically this right here is JSON, right? This is a JavaScript. And you can kind of see the similarities, hopefully. Like it's a little spaced out differently than maybe you would write in Python. But you can kind of see right here, we have this little curly brace, right? We have this square braces right here. We have like a string with quotes around it. We even have this like, colon right here. So if I were to just show you this and I said like, oh, Python code, what kind of Python objects would we think of when we see this? And there's not like a wrong answer. I'm just wondering like what would you think? Like if I show this, what kind of Python code is? Good, dictionaries, right? Yeah, good. So dictionaries have the curly braces right here. And you notice like in a dictionary, especially focusing on something like this one line, you can see we have our key value here, and then our key, and then our value over here, and then another key and a value over here, right? And they're both strings in this case. So this is kind of like a dictionary. If you notice like this part, this one's a little more subtle. But if you see this square brace right here, when we see square braces, what do we think of in Python usually?
List.
Good. I saw someone mouth it. I heard Hazel say it. So list, right? So yeah, this is basically going to be translated as a list. And you can see here, this is one item. You can think of this as a list of different items, okay? So you can kind of see the similarity in JSON, and we'll actually translate this directly into Python, how this works. But just know that this is a completely separate thing from Python. It's just a file format. So note that we can have different things in there. One are called objects. In JavaScript, our dictionaries in Python in JavaScript's objects are kind of like dictionaries in Python. So note that we can basically in each different types we have basically objects, which will be translated as dictionaries, arrays, which are like lists in Python, right? So this is our array or list, okay? We have strings, okay? We can also have numbers. In this case, this file doesn't have any numbers, but you could also have like a number here. Instead of pop-up, have like literally a number 1. Or instead of like file as the key or as the value here, we could have had it like 2, 3, 4, whatever, right? We can also have Boolean true and false. Note, however, JavaScript uses lowercase true and false, not capital true and false, which is what Python uses. So just know that you'll see that difference sometimes. This tends not to be, I mean, I shouldn't say tends not to be. Sometimes it's used there. I tend not to see it as often, probably because it's just more useful to give other information. But just know if you see true and false, it'll be lowercase, okay? And then we also have null values, which a null value in this case, does anyone know what that would probably translate into Python? Any idea?
A none type.
A none, perfect, right? So Null kind of like null is in JavaScript, just lowercase null, but in Python, we would translate that into none. So kind of looking forward is that we can use this for Python. So we actually have this guy right here, and there's a library, just Python library, and no, what's it called? This notebook and the other notebooks, they're still on GitHub, so you can always pull those up too. So you can follow along later. But you can use this library. This is documentation for library right here to use JSON. So it's actually built into Python, which just makes it a lot easier. You don't have to import, you don't have to install anything special. You can basically just read it off of here, right? So we can basically import our JSON, which is just our package, our library. I'm going to open up this file, which we'll see was right here. Okay, and I'll show you what that is before I open it up actually. And then we'll actually take that data. Okay, we'll save it as data and we'll load it. This JSON.load that file. So basically what we're doing is we're opening that file. We don't know what the file is, essentially what's in it, but we'll load this file with JSON, and this will translate the JSON into Python code. And that we can actually use data as if it's like a Python code. So quickly before we load it in there, I'm going to show you what the sample JSON looks like. So this is basically, this is the literal file. So you can see here basically, this is a bigger version of what we just saw. But you can see here, for example, there's this meta part, which is a dictionary, which only has, in this case, only one key here, right? And you can see here, within that key, there's a bunch of other values. You can see numbers here in this case. So you can see here, like, for example, view, there's an ID. It looks like there's some kind of campaign payments, right? It was created at this time. This is probably just like a UTC, what's it called, second string base, or second number, right? So we have all this information here, okay? And you can see it can go kind of deep, right? Some of this information is just like a single number, and other times it's like this information is like a list of information. So it can get really complex, and that's just from like one aspect. And you can see if I scroll all the way to the top, oh, we can't see, but you can see it's pretty long. So like, what's that? Almost 1,000 lines plus, okay? So that's kind of like the whole data, and we're gonna read this completely in. So just know this is just a file, just like a text file. So when we read it in though, read this part in, we put all this through, and actually just showing you data. You'll see that basically that metadata right here, and you can see here is that we have the information, we have our string, we have our string key right here, and then actual values, which could be another array, another dictionary, and whatnot, okay? And just to show you that this is legitimate Python code, it's not just like a string, like, because we could technically just read it all as a string, that's not very useful for us, right? So we can actually read this and say, okay, now this is actual Python code. So data, if you notice, like if I go, I'm gonna go here because it's easier to show. So you can see data, there was meta, and there's also data, okay? So I can't really show this too well, but you can see here data is one of the other keys within this dictionary. So I can say, okay, basically, where am I at? If I look at the type data, let's just do this part. If I do the type, you can see it's a dictionary, right? And we can see here, if I do, okay, if I get just the first part from here, which is called data, well, this data will be what? In this case, it's just gonna be, it's actually gonna be a list. See, that's gonna be a list right here. So if I do this part, you can see the type will be a list, right? If I did meta, okay, what kind of object would this meta be? Like, what is the value of this meta? What kind of object is it? Is it a list, a string, or a dictionary?
Dictionary.
It's gonna be a dictionary. And that's because you can see here, this meta value, or this key, meta key, its value is in fact a dictionary. In this case, you can see that curly brace. So if I actually do, in this case, type data, you can see it's a dictionary, okay? And we could go deeper into that. For example, to pull the next value out of a dictionary, for example, let's do meta and then view. We could do meta and then view like this. You can see here, that's a new dictionary here because we have another dictionary. And you can go like as far as you want down that rabbit hole, right? Like until we reach the very bottom. But the point is that basically we can get each part. In fact, if I just go ahead and print out, for example, let's just go like this. You can see here, there's the ID part. So I could then say, okay, let me just get the ID, right? If I do ID, you can see here, I get that specific part. So this is kind of like how you can traverse like this huge JSON file, okay? So that's kind of cool. It's like, okay, we can load it directly into Python. Basically, in this case, we got our own dictionary. We can do whatever we want with it. We can actually create a data frame with this data. So note there's a couple of weird things is that we have to make sure our data frame actually is going to load useful information. If our data frame doesn't load, like if the data we're loading into the data frame is not formatted correctly, it will have issues. So just kind of be aware of this. Excuse me. So just note for data, we're going to say what the keys are, and there should be meta in data, I think. Yeah. those are 2 different keys. So you can see here, I'm just doing data, meta, data, right? And you can see here, I have our data frame here. I'm loading it into with our pandas data frame from dictionary, okay? So this will create 2 different data frames. For example, if I do data frame.data, which is this guy right here, you'll now see we have a bunch of information, and you can see the columns don't get populated right away. But you now see this information. Note, however, because you can't have a, what's it called, a dictionary within like one element in a data frame, right? You'll see that this dictionary right here gets called basically as its own string. So this is, if I do like, for example, df dot, let's just do this. No, let's do info. Okay, you can see here is that that object basically, that object means it's going to be a string. So it translated that, oops, pressing the wrong buttons. If I do the head now, it translated this cell right here, for example, into a string, because basically it doesn't know what a dictionary is for pandas. So note that if you have a lot of like nested information like we saw, you're going to have to kind of figure out how to deal with those nested information. Okay, but in general, we can put it out in an actual data frame. Cool. Any questions so far about what I'm doing, how I'm able to kind of iterate through this, translate into Python? Thumbs up so far, thumbs down, sideways. Cool. All right. Straightforward so far. Awesome. And just know we can do the opposite. We have a data frame. So let's say, for example, you can see here, I have this data right here. In this case, turn on data frame. This is actually direct Python code, right? So this would actually create my own dictionary right here. So I could do like data, for example, menu. Oops, geez, I can't talk today. Data.menu, you can see here, basically it'll return this part. So like, this is just regular Python code. It's not JSON, right? So if I did want to export it into a JSON code itself, I can actually do basically open up a new file, output.json. I can write to it, okay? And just know this is basically just how to write to a file. There's more documentation on how to write to files and stuff like this. Usually we like to use like pandas, for example, to do all the dirty work for us, but this is how you would do it in basically pure Python. And you basically do this json.dump. Just to kind of show you what this does, is that if I do, oops, let's go over here. If I run this right here, oh, duh, because I can't write to it. Okay, so let's go. Sorry, I was trying to show you guys what dump is, but basically, I think I can just dump it to, let's see there. This is why I don't like live coding, because I will mess things up. Okay, so we do need a file name. I was trying to show you guys it would just export into a string, more or less, but since we can't show you that, I'm just gonna go ahead and run this part. And this basically what will happen is I'll write to this file as a string, basically, and it'll dump all this information that's here into a JSON format. So if I write this down, it'll output that out, and you can see here I have my output JSON example, and you can see here I have a nice little document. This is a .json file. So basically I can now pass this over. So what's nice about JSON, having these kind of formatted files, is that I can now basically pass this information back and forth to not just like other, like programs within my own stuff, like, oh, I'm gonna keep this information in JSON format for me to later look at. I can also pass it to other computers, for example. Like I can send it over the network, or I can send it even to JavaScript, or I can take basically from another computer or from someone else, take this file, load it into Python, where they never intended it necessarily to even know Python. They don't need to worry about it. They just have to have this data format. So it's kind of nice. It's kind of like a CSV, but obviously this is a little more complicated than CSV because we have a lot more information, right? We have a lot of nested values versus tabular data. So just know that this allows us to basically have like essentially like a more universal file format, okay? And know that we're gonna talk about XML in a second, which is something very similar, but know that they do very similar things. In fact, you can translate JSON into XML and XML into JSON. JSON tends to be seen as more modern. Most modern systems will use JSON. It doesn't mean people don't use XML or both, but XML tends to be more on older systems. Older systems or well-established industries will tend to use XML over JSON. And you'll notice a lot of more modern companies will tend to use JSON instead, okay? So that's JSON, and that'll lead us to XML, okay? So XML, you can kind of see it's kind of similar here. In this case, if you're familiar with any HTML, it's very similar. Basically, it's a generalized HTML. It stands for Extensible Markup Language, but we use the X because X is cool, apparently. So just know that this essentially right here is essentially not markup language. HTML, but instead of having a hypertext, which is what HTML stands for, it's extensible, meaning that it's basically flexible. You can use whatever you want. So this note, for example, this is just like someone decided to say, oh, I'm going to make this say, make sure that you know that all the stuff within here is a note. And then say, okay, whatever within this note, there's a to field. Okay, this is going to be part of the to field. This is going to be the from field. This is the heading right here. So these values right here for heading, body, note, those are all just values of whatever you want to call it. Similar to how we have, like, for example, in this guy here, a menu, an ID, a value, a pop-up. You can define whatever you want. That's the kind of what XML essentially is doing here. Note that it doesn't have to be a string within here. It can also be like a number. It doesn't have to be another value like that, okay? So once you have this information, okay, you can actually end up parsing it with Python itself. Note that because, well, I don't know if it's because JSON is relatively new, there are a lot more like simplicities with JSON because people have kind of made it nice and easy for you to deal with it. XML is kind of like treated as like the second child, being like, oh, there's the you too, like, but we really like JSON better, unfortunately. So just know that it's a little more difficult to deal with JSON or XML. It's a little more work than you simply, like you saw here, I simply just did like, okay, JSON dot load, right? Like that's as simple as that. Python's gonna have to be a little more complicated. So you can see here, for example, I have to import, it's still built into Python, but just know it's a little more work. I have to basically import this as this library, which is eTree, element tree, and then people usually export as something small, so you don't have to repeat this whole thing again. And basically this et.parse will take in a file called sample.xml, and basically that will load it into Python so you can actually go into it deeper. And we'll see what that looks like in a second. And then I can actually see, for example, we call it like a root, a tree, kind of like because you can like go, like you can also think of like JSON as a tree too. Basically you can like go deeper and deeper. And so what's weird is that computer scientists decided this, is that a root starts at the top of the tree in a way and then kind of goes out, I guess. Like in my mind, I kind of go downward, whatever. But the root basically is the very first element. It's kind of like the top element. So this right here would be our root. And then down here would be our different nodes, okay? And you can actually have nodes within nodes, or you can think of it like children. Basically like this is like the parent, this is the child underneath it. There's different ways to phrase it. They're just interchangeable. But I wanted to show you first what this will look like, this sample.xml. So let me show you the file. So, oh, I forgot. So right now you actually will notice that there's no extra spaces, and that's because XML is really built, or XML and HTML is built around for, or web browsers can read XML and HTML really well. So what happens is that basically you try to read this in, and the browser tries to figure it out. So you'll see that I can't actually read this. If I tried editing it, I could show you. But to show that instead, I am going to, oh, here it is. No, sorry, I'm just going to download this. What the heck? Okay, I just realized I have it in another folder. You can't see this part right here, but I already downloaded it beforehand. And what I'm going to do basically is just going to open it in the browser so you can see what this actually looks like. So I'm open with, come on, Mac. So again, I'm just opening it up. I know you can't see it right now, but trust me, it's the same exact file as that sample.xml, and you can see it here. And so this is, for example, is how the XML is more or less formatted within, what's it called? You see XML file, right? Basically how the browsers will read it. So you can see here, for example, I have a row here. So this is the tree, or the root. This would be like its first child. And you can see each of this row right here has another child. In fact, it has many, many children underneath here. And in each of these rows right here, you'll see that it has this long thing. Basically, there's this child of the row here, child, another child, basically all these different values here. You can see office distance 32, can, class, P, I don't know if these are primary page. This is like campaign information. So you can see like there's basically a bunch of information underneath here. One thing to note too is that there's also this information up here, which is not what exactly we saw in JSON. This right here is basically just extra information that belongs to this tag. We call these tags this row with this little triangle brace. And this information right here is basically just extra information. This kind of like, you can think of it like metadata, basically explaining what this tag is. So know that sometimes your information that you care about as a data scientist might be within here. Usually it should be within the actual children, but because people do whatever they want and give you that information. Sometimes this stuff can all be put into like one tag, which is awful design, but it happens because people are people and they can do whatever they want, right? So just know that there's also information in these tags, and I'll show you how that goes through. So now that you saw what the XML file looks like, I can go ahead and read it through really quick, right? Basically, it grabs its root, okay? And we can actually see, for example, let's go ahead and show you what root looks like. And you'll see here it's actually an object, right? So it actually has a special, a special thing you can do. But it's nice is that it is an iterable, which means basically you can use it within like a for loop. You basically do this part. So for example, if I want to get the first children, I can basically go through with a for loop, a list comprehension here. So this way, basically for node and root, for basically, I'll go through that root, and you can think of when I looked at, let me close these guys so we don't keep putting them up. Where did I open? Oh, there it is. Okay. So you can think of like within the root right here, it's going to be row, and then we basically can get each of those parts. So basically for the first children, it'll just be row. So let's see if I can do this right. So let's do print first children. Okay, so this will basically go from the root, which is the very top, and say for each node, and it'll just give me the node. So this should only be like just root. And you can see here, there's just one element in here. So just to kind of prove you guys again, that it is in fact one element. You can see there's one element in there, okay? And that's because it's only containing this row element, okay? And so within that children, okay, so in this case, I'm actually doing some kind of fancy footwork right here. I could have just replaced this with first children, but this is kind of showing you how you can go deeper and deeper. Basically, the first thing I do is say, okay, within root, so for node and root, and then for each grandchild in node, it's going in deeper each time. It's going to basically grab all the grandchildren. So you can see now, if I do grandchildren, you can see now, basically there's a whole bunch of things. For example, we can see how many rows, and each one of those parts is now, so it's 285. And if I were to scroll all the way to the bottom here, you can see that there's 285 rows. So you can see here, basically each one of those elements in that list now, in that grandchildren, is that row with information on it, okay? So just know that it's stored in a different way than it is in JSON, okay? So it's not directly relatable to Python, okay? And then if you want to check out more, for example, we can start doing, for example, seeing what the tag is. So remember when I said like the tag is essentially, is it a row? It's this part right here is the tag. So you can see, for example, these are tags. And then we have our attributes, for example, right here, .attribute. These are our different attributes. And know that we can have multiple attributes within a tag, okay? So you can see here, if I do print tag, row has nothing interesting, but when we get to grandchildren, we can actually see, for example, the very first row, okay? We can see, okay, it's actually a row element, right, for our tag. We can see our grandchildren.attributes, and basically it has a list of attributes here. For example, it has ID1. You can see here, if I scroll up to the top, where am I? Here. So you can see, for example, ID equals 1, UUID is long thing, position equals 1, and you can see all those parts right here. Okay, and that's how you would get the attributes, for example. Okay, so this is kind of nice. This is generally kept as like metadata for your tag, saying something specifically about the tag, and then within that tag, if you have children underneath there, then you would actually have more information. So you can kind of see, like, you can kind of navigate this through. For the most part, it tends to be a little cumbersome. It's not the most fun thing. I mean, in my opinion, not the most fun thing to kind of iterate through. JSON tends to be a little bit easier to deal with, like in a Pythonic way. Okay, and you can see here, I can go through the whole tree. For example, I'm just going to go 0 to 40, basically just go through 40 different children. And you can see here, as I can say, okay, go ahead and go for each element in the root. Go ahead and go each part and just going as deep as possible. And we're going to print out each element and attribute. And I think this actually comes from the curriculum. So just know you'll see this again. I'll explain more. But you can see here, for example, I go to the response, and then go for row. And then within row, I see all the attributes for row. And then go for each part. You can see like the row, for example, has candid, can name, office, borrow, can class. And you can see those all show up right here. And then I go to the next row. And this row has different tags, election, candid. So basically what I'm doing is, I can show it on here. I keep using my hands. I don't need to use my hands. I basically go into response, and then go into row. And then within row, I go into this guy, and then go, okay, this one, this one, this one, and then hop out of row because row finishes, and then go to the next one. This one, this one, this one, this one. And you can see, for example, election, candid, can name, office. Oops. You can see that pops up right here, candid office, all this part, okay? So that in general is just kind of how you would go through your XML. So again, I think in my opinion, it feels a little more work than JSON, probably because you have to do a little more than just using Python directly. So in my personal opinion, and what I've seen in the past, people tend to use JSON because it's usually easier to work with, okay? But you can get the format anyway. And note, you can also create a data frame with XML, but you gotta do some more work. You basically have to go through it and make sure you have the right format before you actually load it into your data frame. So you can see here, if I run this now, you see now I can have a data frame, but I had to like do a lot more information, basically make sure I get this right element and make sure I actually get the stuff that I want for the data frame. For example, this is just attributes. So in this case, I didn't even go into the tag, inside the tag and actually get those elements in there, which can be formatted however you want. As you saw, they don't have to all be the same, each part within that tag. Okay, so for example, this is candid 9, and then this one had like another like 8 or 9 different children in there. Okay, so I kind of went through that kind of quickly, but I think mostly it's not too unexplainable. Thumbs up, thumbs down. Any questions about this?
I have a question about the dot transpose. What is that?
Oh, where do you see that real quick? Is it on this page right here, or? Yeah,
in the first for loop right there at the end of it.
Oh, okay. Dot transpose. Yeah. So what's going on here? Let's kind of go break this down a little bit. So our DFS dot append, basically this is a list, right? And we're appending all of this stuff right here. Okay. So basically we have our data frame in here, and this dot transpose. Oh, I'm sorry. Make sure I got this right. Sorry. This right here is our data frame right here. Our dot transpose basically flips it over. So if I didn't keep this in here, maybe I can actually show this. I don't know if this will work well, but we'll see. Okay, you can see here, basically what happens is that we have our, what's it called? Our attributes are actually down here, but then our elements that we actually care about are on the side. But it makes more sense for us to have each column to be our part. So we can do a dot transpose. Essentially, the way I think of it is like it flips it over. So our columns become our rows become our columns. So this allows us to basically have a more traditional data frame like this. Okay. And that's really, this only comes from the fact that this is not general. This is like because I specifically know that this data is formatted in a specific way that I have to do a transpose or I read it indifferently. Again, it all comes down to understanding what your data looks like before you start doing this. There's not usually a general, you can't just make this a function and then throw it to any XML you want. It ends up being a little more complicated than that. That's why, again, it's kind of nice to have the JSON format because you can read it directly into read it directly into Python code. And Python code, I think in general is a little bit easier to understand how to like navigate through it versus XML. You have to think of it like within classes and stuff like that, which I guess maybe some people enjoy that, but maybe not. A good question. Any other questions that you guys had, either from code or XML in general? Okay, cool. All right. So I mentioned before comparing the two. Each one can be translated into itself. There's this nifty website right here that actually shows you JSON examples and XML examples. So it's kind of cool that it shows you like the same exact information, but it's written in JSON or in XML. You can see, for example, I actually got this. This is the menu. This is where I got it from. This is the menu in XML form and JSON form. So this is kind of a nice, cool little website that kind of shows some examples. So a good thing to check out. And it's right here linked in the notebook. Okay. But the main thing is that JSON and XML, they're essentially really flexible. You can do whatever you want with them. They're not like CSVs, you basically have columns and rows and that's all you get. JSON and XML, you can basically have different nesting in there. You can kind of make whatever kind of columns you want. You can have essentially nest with a nest with a nest with a nest kind of deal, which makes it very flexible, very easy for anyone to basically export the information and get it out. JSON is considered more modern. Most people prefer using JSON nowadays versus XML. XML considered more old school. And you'll see when you see HTML, for example, or if you've seen HTML, it's basically a generalized HTML. Okay, cool. So any other overall questions for XML, JSON, reading it, anything like that? Okay, thumbs up, thumbs down, sideways, feeling good? Okay, hopefully you're feeling hopefully this is feeling like a little break. It's like, you know, I showed you some code, but it's like it's not like too crazy, right? But we've done so far. Like you guys just did linear regression. Like this stuff's easy now. So again, this is just a way to get data. So good to have. All right.